you go. Okay, first, you have glycolysis, right? Okay, well, the whole process of everything we're trying to do, what's the point?
Make glucose into ATP.
Very good. So we have to do that in 3 major steps. You have to do it in glycolysis, the citric acid cycle, and the electron transport chain. Those are our 3 big steps. Up here we only have 2. We'll do the electron transport after this. Good deal? Okay. This applies only for 1 glucose molecule. Okay. So here's glucose, all the way up here. Glucose is a 6-carbon chain. As long as I see somebody writing it, I'm going to keep going. I want to make sure everybody gets everything.
Where's your freaking phone?
Okay.
Where's your phone?
Me?
Her. What are you writing? You're holding this up.
Tracing me. I'm already saying Tracy because I'm like, oh, wait. Here, why don't you hold this for me so I can write at the same time?
Alright. You're a kitty cat, you can do everything at the same time.
Now, if my phone messes up and it doesn't record,
It's going down. Okay. So you start glycolysis.
wait, it's
First of
not
all,
starting. Sorry.
Oh, okay.
There you go.
Okay. Glycolysis is something any cell can do. Let's start with that. Glycolysis is without oxygen. So it happens outside the mitochondria in the cytosol, right? Because the mitochondria uses oxygen to do everything that it does, right? So we don't need that right now. We're going to start outside the mitochondria in the cytosol. We're going to go with 1 glucose molecule. It's 6 carbons long. So there's my little chain. Okay. Now, we're going to phosphorylate it by adding a P to both sides. Are you out? Oh no, we didn't go 32 minutes. You said I had 32 minutes. Why?
That's okay, Natasha. Lori will send it to you, baby.
Okay, so you're going to add a P to both sides of this 6-carbon chain. There's a fancy name for it, but you don't have to know it. Okay. When you add a P to both sides of glucose, that costs the cell 2 ATP. It takes us energy to put P's on the end of things. So that's going to cost us 2 ATP. Then we're going to take this long molecule and split it right down the middle. Now we have just 2 halves, right? Okay. Anytime you cut a molecule, you're going to do something called liberate hydrogen. Because hydrogens are going to have nowhere to go. Because once you cut it down the middle, all these new bonds are going to form between the carbons that are next to each other. So then hydrogen's going to kind of float off, but it needs to have a babysitter. That's going to be NAD. NAD's going to come in and pick up the extra hydrogens. Okay? So NAD is just a babysitter, just a carrier. It takes those. We're left with these 2 halves, right? Then we're
So
going
is
to
it babysitting the energy of the hydrogen and the electron? So
the hydrogen.
it released energy when it split right there, right? And it went over to the...
Well, yeah.